Hi everyone, this is John Hope. I'm the facilitator of the real-time working group. And I've been asked a couple of times recently about the progress of real-time, so I thought I'd make a quick summary video to demonstrate the first feature that uses WebSockets and talk about the next steps that we're taking to make it easier for teams within GitLab and members of the wider community to build real-time features using WebSockets. So you may be thinking, don't we have real time already? Maybe you've been adding a comment to a discussion thread and you've seen another comment pop in before you were finished, or you're looking at an issue description and it changes while you're reading it because somebody else edited it. And the answer is yes, we have an approximation, if you like, of real time that uses a technique called short polling. Short polling is fine for this use case and it's time tested, but it does have one downside, and that's that it's not instant. There's a polling interval, and in our case that polling interval is 3 seconds. So if somebody makes a change to an issue, you might not see that change for 3 seconds or more. That's not ideal for our ultimate goal, which is collaborative editing of issue descriptions. So the purpose of the working group was to discover and implement a solution that's low latency, that's reliable, and that gets us closer to the goal of a snappy, truly real-time application. And we chose WebSockets implemented via Action Cable. Action Cable is included with Rails. It uses Ruby, so we understand the source code, and it's relatively mature, so its limitations are well known. So what I'll do now is just I'll demonstrate the first feature that uses WebSockets for a real-time experience. And this feature was built by Heinrich, who's really driven the real-time project from the start and has stewarded this feature all the way to production. The feature is Assignees on the issue sidebar. So what I've got here is two browser windows open side by side looking at the same issue. You can see nobody's assigned. So I'm going to assign myself, and you'll see the Assignees update here on the right. And that's it. That's the feature. This is available to everyone on GitLab.com. It's been enabled for over a month. It's also available to self-hosting customers who enable the feature flag, and they have a number of different ways they can deploy it depending on their cluster size or instance size. And you can try it yourself. I mean, you don't have to have two browser windows open side by side. You can just use quick actions to assign or unassign yourself and see the sidebar update in real time. So although this is a small feature, it actually represents really good progress. We encountered a number of challenges on the way to delivering this first feature, going from 0 to 1. For example, in order to support this feature, we have to maintain an open WebSocket connection for everyone who's currently viewing an issue on GitLab.com. And that peaks at around 40,000 open connections, sometimes spikes even much higher than that. And these differ from your typical HTTP traffic that you would see on the web app, which is short-lived and it's stateless, and it's designed to facilitate the request response cycle. These are persistent open TCP connections that are intended for bidirectional communication. So what we actually have now is a completely separate deployment on Kubernetes. These are pods that contain both workhorse and web service containers, and they're specifically for serving WebSocket traffic. So we route WebSocket traffic at the Nginx stage to this infrastructure. The infrastructure is completely isolated and it's independently scalable, so there should be limited risk to the rest of the web fleet. So this is just one example of why the cost of implementing the first feature was so high, and it's taken us a while to get this right. So where are we going next? Well, we have an OKR in Q1 to mature real-time, and you can follow it in this epic. If the OKR is successful, we'll have refactored the current implementation to a sustainable state. We'll have provided metrics and developer documentation from which any team can self-serve to build real-time features using WebSockets. We'll also understand the cost of scaling connections to new parts of the application. But there's already a proof of concept here built off of, branched off of the work to refactor to GraphQL subscriptions. The proof of concept is built by Phil Hughes, and it's real-time MR widget states. So as soon as we know the cost of supporting connections on MRs, we'll have a next feature to implement there as well. If we're successful in this OKR as a whole, we'll have unlocked WebSockets as a usable technology for the whole team. And while I explained the fixed cost of supporting WebSockets and implementing the first feature was high, the marginal cost of adding new features is comparatively low, especially in the case of adding new features to the issue view page, which we already have a connection we can reuse there. We can have as many features on it as we like. So that's where I'll leave it for now. You can check out this slide deck if you'd like more information, or you can follow along using the Epic for the OKR for this quarter. We also have a Slack channel. You can reach out to any of the DRIs as well. And if you'd like to read further into our progress with real-time, you can use the working group handbook page or the design document, and depending on how far you want to go, there's links there to where discussions where each of the decisions were made. So feel free to reach out and I'll be happy to answer any questions you have.